Chapter 3, Section 7, Question 1. Boring lines again. Yay! So if you remember, an x equals 3 would be a line at x is equal to 3, and it would be perpendicular to the x-axis. So something to think about. The x-axis goes this way, and x equals line goes this way. But then, we know that it goes here. But let's look at this inequality. It says greater than. Greater than says shade larger and use a dashed line. Why is it a dashed line? It's a dashed line because it is not equal to. So some people say dotted line, but I don't know about you. I'm not going to make a whole bunch of dots. So there's my dashed line, and we have to shade greater than 3. So we take a look, which side is greater than 3? Are 2 and 1 greater than 3, or are 4 and 5 greater than 3? It's 4 and 5. So we're going to shade this way. Now I'm going to start off parallel to the line, and then after that I can just blah, ta-da, yay. Now I'm going to use a different color for this next one. Y is less than or equal to 2. Remember the y-axis goes this way, so a y equals line, boop, will go this way. So we're going to make the y equals line here at 2. Holding our straight edge firmly in place, but before we draw it, we're going to take a look. It says less than or equal to, that says shade smaller and use a solid line because it's equal to. So we want to make sure that we have our line equal to, and then we want to shade less than, which is smaller. Which is smaller than 2? Is it 3 and 4 or 1 and 0? 1 and 0. We're going to start off parallel and then keep going. Now, what this is called in geometry is called a half plane. A plane is a flat surface that goes on forever in both directions. So as we slice it, we're going to shade everything on one side. So some people will just shade a little bit and then stop. That would actually be wrong. You want to keep going for the rest of that. Some students are also very artistic. They'll actually do a beautiful job of shading. And the thing is it's not an art class. In the event that you make a mistake and you've just done the world's most beautiful shading, some people aren't willing to erase it and put their line in the correct spot. I would rather your line was in the correct spot and you shaded on the correct side of the line, you knew the difference between solid or dashed. Because this is chapter 3, section 6, and we haven't gotten on to our next chapter, as long as your line is in the right spot, I will give you half credit. As long as the solid or dashed and your shading is correct, that's where your other half credit comes from. Next chapter, it's going to be worse. Get it right now. Chapter 3, section 7, question 2. This is a fairly new problem, and the reason is students were struggling when we made this problem harder in chapter 4, but we had not reviewed it in chapter 3. So we put it back in chapter 3. You'll remember these problems from back in chapter 2. They're solving with absolute values. That would be in 2.6 if you need to go back and review. In that chapter, we made 2 equations. We had y plus 3 is greater than negative 2, and y plus 3 is less than 2. Why was this one changed here and here? It's because the inside of the absolute value could be negative or positive. Here, the inside of the absolute value is positive, so nothing changes. Here, the inside of the absolute value is negative, so when we divide both sides by negative 1, dividing by a negative flips this sign, and 2 divided by negative 1 becomes negative 2. Most teachers do not require you to show that step, but we want to make sure you know why it's happening, because it's not magic. And then we're going to solve. From back in chapter 2, we can actually solve these the same way, but we're going to come up with different answers. Negative 2 and negative 3 gives you negative 5, and positive 2 and negative 3 gives you negative 1. Ooh, they're different. So we're going to have to make a line at y is negative 5 and y is negative 1. The y-axis goes this way, so remember, if the y-axis goes this way, a y equals line goes that way. Y equals negative 5. Now, solid or dashed? It doesn't have the bar under it, so it's going to be dashed. Now be careful, look how many dashes I'm having. I'm also going to make some dashes off the edges of the graph so that I can tell later on after I shade, especially for the students who do really good jobs of shading and then we can't tell the difference as teachers as to whether or not you have a solid line or a dashed line. I had students who drew solid lines and made a note that it was dashed, and I said, I cannot choose for you which is the correct one. Now, back in chapter 2, we had things to help us remember. All right, so for those of you who are tactile kinesthetic learners, this is really good for you. Absolute value, greater than goes out, absolute value less than goes in. So here, this is an absolute value with a less than. Less than, we're going to shade inside, meaning between these lines. Now, parallel, 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 not crossing that line, and then going until parallel, 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 we get to the other, we've shaded inside. That is the answer. Chapter 3, Section 7, questions 3 and 4. So you're going to have some problems just like this. So it has a reminder from back in chapter 2 that we have to flip the inequality when we multiply or divide by a negative. We actually reviewed that last question. So we're going to solve for y equals mx plus b. Haha, we are going to have to divide by a negative. Thus our evil plan. You're going to get y is, we're going to have to flip that sign to greater than or equal to. Negative and negative is positive 2/3. The x can go in the numerator or it can go afterwards. It just cannot go in the denominator. Positive and negative is negative. 6 divided by 3 is 2. Woohoo! All right, so just like graphing a line in slope-intercept form from a previous section, we're going to start off at -2. And we're going to count 2 over 3, which is up 2, right 3, make a dot. Up 2, right 3, make a dot. Down 2, left 3, down 2, left 3, down 2, left 3, down 2, left 3. That's where we're going to make our line. Then we're going to have to take a look at, of course, keeping our straight edge very steady against a slippery whiteboard. Solid or dashed? It has the bar underneath, which means it is solid. Past the edges of my graph, arrows at both ends, and then it says greater than. Greater than means up. Now, if we look here, that says less than. But with the less than, I had to divide by a negative. That's why it switched to greater than or equal to. This is another reason why we want to solve for y equals mx plus b. As long as the y comes first, it tells us which way to graph. It will continue doing that when we are graphing inequalities with parabolas and absolute values. So greater than, we're going to start off parallel to this line and look how that, I want to hit all these areas because some students have stopped at these lines and they didn't shade the rest of that half of a plane. Chapter 3, Section 7, Question 5, Type 1 of 2. Hey, it's like foreshadowing. I just talked about how we would have to do this with our parabolas. You might remember that we were doing this back in Chapter 3, Section 1. We're hitting it again right before your test. Can you graph this? Now, if you remember from Chapter 3, Section 1, we did it using a t-table. I also talked to you about ways that you could do this faster. So if you do not require a t-table, that's fine, but we do want to make sure that you can do it with a t-table. If x is 0, 0 squared is 0, times a negative is still 0, plus 3 is 3. 1. 1 squared is 1, times a negative is -1, plus 3 gives me 2. 2. 2 squared is 4, times a negative is -4, plus 3 is -1. So back in Chapter 3, Section 1, I actually showed us plugging it in, but if you don't need to show the plugging in work, that's fine as well. -1 squared is +1, times the negative is -1, plus 3 is 2. Hey, it's that same pattern. So -2 is going to be -1. We might need to go further. Let's see, 0, 3, 1, 2, and the same thing on the other side. 2, -1, and the same thing on the other side. I might be able to go one further because look at all this space down here. I'm going to go with 3. Since I'm not being graded on my t-table, I'm going above. 3 squared is 9 times negative is -9 plus 3 is -6. So 3 -6, it does fit. So yay, we are going to have to get that. Take a look at that. That is 7 points that we'll have to find. And then we'll have to graph that out going, whee, hitting all the points, arrows at the end, slightly past the edges, and the other way, whee, arrows at the edges, slightly past the edges. Now, I forgot to check. Is this supposed to be solid or dashed? It has a bar under it. It's supposed to be solid. Good job. All right, now it says less than. Less than is below, so we're going to shade below. Now, I can't really do something parallel to this, so I just need to make sure I stay inside the lines, 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 ta-da, that works. Chapter 3, Section 7, Question 5, Type 2 of 2. We are still graphing our inequalities with nonlinear equations. If you remember from Chapter 3, Section 1, there were 2 main types. There were the parabolas, and there were the absolute values. These are the absolute values. I left up my t-table here. I still want to start off plugging in 0. So absolute value of 0 is 0, times negative is still 0, plus 3 gives me 3. Hey, that's where we started off last time. We're starting to get patterns that we're seeing, hopefully, in graphing, which will eventually get us to the point where we won't need to use a t-table. But the t-table is always there because you'll find that as you go into future math classes, we'll give you strange equations. As you go into your SATs and ACTs and AccuPlacers, we'll give you strange equations that you may never have seen before, but plugging in will still work there. All right, 1, absolute value of 1 is 1, times negative is -1, plus 3 is 2. Absolute value of 2 is 2, times negative is -2, plus 3 is 1. Absolute value of -1 is 1, times negative is -1, plus 3 is 2. Absolute value of -2 is 2, times the negative is -2, plus 3 is 1. Hey, it's got the same pattern here. Now, if you remember your absolute values from 3.1, it made a V shape. It is a negative absolute value, that's why the V is going upside down. And it also made straight lines, so the thing is we could continue doing our t-table, but if we use the pattern of down 1, right 1, 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 down 1, left 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 1, that is not my best dot. Let's try that again. Once we see the pattern and we know that the absolute value is supposed to make 2 lines that meet here at this point, then we go all the way, slightly past the edges, arrows at both ends. Do not cross over here, because some people try and make this into a little X. It's supposed to look like an upside down V, so it doesn't go past on either side there. Now, I forgot to check again. Is this supposed to be solid or dashed? Oh no, the bar is gone. It's supposed to be dashed. I am on a whiteboard, so this is a wonderful time to make it dashed. It is fun to make it dashed on the whiteboard. However, if you're doing it on paper, you're going to have to use your eraser. If you're doing it in pen, you're in trouble. This is why we do not use pen in a math class. Then it says greater than. Greater than is shading above. We're going to have to shade from here up, which means we're going to have to shade coming up this way and coming up this way. All that stuff above. Last time we had less than, in which case we shaded all of it